without waiting. So, good morning to all of you. In the last class, we have discussed about the important characters of the fishes, that is what we call the general characters of the fishes. And all of you know, the fishes are very fascinating organisms. They are very fascinating because we develop fascination about the fishes from our very childhood. And another very important thing is they are very, very important economically also, ecologically also, aesthetically and recreationally also. So they have become almost a part and parcel of our life. So that's why the studying the fishes is a very, very important thing. And in that we have already listed out some of the key characters or the general characters of this series species. Now, if we move on to the classification of the fishes, all of you know they come under the subphylum vertebrates, the one which are having vertebral column and pharyngeal gill slits. And then there are about 45,000 species in vertebrates. In that, there is one class, in fact, there are four classes. One is class Agnata, the Agnata. Gnata means jaw, jawless fishes, hagfishes and lampreys. That you have studied under the protocols. Then the second class is the chondrichthyes. So this chondrichthyes, in simple term, I may say that they are the cartilaginous fishes. They are the cartilaginous fishes, which include sharks, skates, and rays. Second one is the modern fishes, osteichthyes or bony fishes. Then there is also one more class, that is Sarcopterygi, lobed fin fishes, especially the lungfishes and coelacanths. About them we will come later. Now, if you look into the classification of these fishes, see, this is how first, this is the line of evolution wherever the base, from here there is one group evolved into chondrichthyes. Then one more group also diverged, and that gave rise to lot of other organisms also. In that it has further bifurcated, and coelacanths, lungfishes, amphibians, mammals, and reptiles, birds, everything originated from this. So that means, as far as the origin of this chondrichthyes or the cartilaginous fishes are concerned, they have a separate line of evolution. Even here in this photograph, which if you can see the chondrichthyes, the sharks, rays, and all those things. They have a separate line of evolution, whereas modern bony fishes have another line, and in that there may be some further division. See, this is the chondrichthyes, elasmobranch fishes, which have a separate origin, and this where my cursor is moving, if you can see, the modern fishes or bony fishes have a separate origin. Here also we can observe the same thing, that is the elasmobranch fishes, separate origin, and the other osteichthyes, they have a separate origin. Now, the first one, which though you have studied that, the Agnata, the jawless organism, there are 80 species. Most of them are having round mouths, slimy skin, no plates or scales, notochord is there, is there. Mostly they look like a snake, eel-like. cartilaginous endoskeleton, unpaired fins, marine or freshwater they may be. So that you have studied separately. And here we have lampreys and hag, hagfishes. Lampreys, most are parasitic one, and they suck the blood and body fluid from the other fish, because these lampreys have highly developed sense of smell. Uh, Here on the tongue you can see the teeth, and there is also a hole there. A chemical is released uh, to prevent fish's blood from clotting from this, and they have no stomach. Another example for this agnatha is hagfish mixing, found in the cold marine water, especially in the temperate oceans at the bottom. They feed on, they are scavengers because they feed on dead and dying other fishes of the ocean. Here also you can see a hole in the fish with a toothed tongue, and that is a specialty. But have cranium and endoskeleton, but no vertebrae. Uh, we are not much concerned about these two things. We are more concerned about the two groups, two classes of the series species, what we call series species, in the chondrichthyes and oxycthyes, because most of our fish fauna are from these two classes, that is the chondrichthyes and oxycthyes. Though there may be few examples from the holocephali, but majority of the fish folk that we observe, eat, use, that comes from chondrichthyes and another class, the oxycthyes. First, let's try to understand about the chondrichthyes. Probably these chondrichthyes are the oldest fishes, I can say that. Compared to bony fishes, these fishes are the oldest one. There are 800 species, which includes the most popular fishes, as all of you know, the shark, skates, rays, and all of them are the marine dwelling organisms. They are found in the oceans and seas, salt water. There are 800 species coming under this contract. The unique feature is these are the fishes with jaw, movable jaw. They can move their jaws, masticate, and endoskeleton is made up of cartilaginous material. Endoskeleton is made up of cartilaginous material and movable jaws. These are most of the members of this chondrichthyes are carnivores with large olfactory organs, so they have a very good or a very powerful sense of smell. Because of large olfactory lobes in their brain, they have very powerful sense of smell. And even the lateral line system is also very well developed here. Body is covered by a scale. The name of the scales, that or the type of the scale which cover these chondrichthyes, it is known as placoid scales. They are very small, tooth-like spines. The scales, I will show you later how that appears. They are small tooth-like spines, and if you touch it, it looks like a sandpaper. Oh, see, this is the tooth-like spines. These are the scales, pointed scales, backwardly directed, pointed tips. So these cartilaginous fishes have made the or are made out of the cartilage, which is lighter. All of you know that the cartilage is lighter and more flexible. In our body also we have cartilage, where our ear pinna is made up of cartilage, so you can twist it. Our nose is also, external nostril is also made up of cartilage. And there are many other reasons, wherever the bone joints and all those things, where You can see the cartilage. So these cartilages are, compared to bones, they are lighter and more flexible. All these cartilaginous fishes have very well developed jaws, and they also have paired fins for swimming. Paired fins. Pectoral, pelvic fins are paired. So most of the fishes have a rough sandpaper like skin because the skin is covered by these placoid scales. Here if you rub the fish from anterior to back posterior, it appears smooth because all scales are backwardly directed. Suppose if you touch it from posterior to anterior, rub it like this, then it will be like a moving your palm on a sandpaper. Rough, it appears very rough. So these cartilaginous fishes are mostly made up of three groups of fishes. They are grouped under sharks, skates and rays. This cartilaginous material is made up of cells that are surrounded by tough fibers of protein. They are tough but light in weight as well as more flexible. The, they have a movable jaws and uh, some of them, most of them are carnivores, as I have told you. They are the predatory fishes. They hunt on other fishes. But there are certain carnivorous fish, cartilaginous fishes, that the chondrichthyes, which are also scavengers. That means they feed on dead and decaying organisms. Uh, Now, these cartilaginous fishes are very well adapted to marine water. The gaseous exchange occurs in the gill, which just lie behind the head. And this one more important thing which I have forgotten to mention is the gills are open. Gills are not covered. There is no operculum, unlike the bony fishes. Bony fishes are covered by operculum, the gills are. But in cartilaginous fishes or chondrichthyes, there is no operculum. Uh, they are fast moving. Even if you see the fast moving shark, that push water through their mouth over their and gills and out their gills this by swimming. Most of the cartilaginous fishes pump water out of their gills by expanding and contracting their mouth cavity and pharynx. So when the water passes through these gills, the blood capillaries which are lining the gill lamellae undertake the process of gaseous exchange. Uh, most of, but in some rays and skates, they draw water through their spiracles. Spiracles are nothing but two large openings which are situated on the head just behind the eyes. There are two large openings, and the water enters through the spiracle and forces out through the gills. So gills are continuously bathed in marine water, and the gaseous exchange happens continuously. As far as the excretion in case of these cartilaginous fishes are concerned, cartilaginous fishes do not release ammonia as the nitrogenous waste product, but they make use of this ammonia for the generation. Fishes use energy. They use energy to convert ammonia into urea. By investing energy, they convert ammonia into urea and then excrete it. But before excreting, most of the sharks retain large amount of urea in the blood and even in the tissues. This is a very important mechanism for osmoregulation. By retaining the urea in their blood and tissues, they raises the concentration of the solutes in their body at par with the surrounding water. Otherwise, all of you know, uh, they are in the marine medium. Because of the dissolved salt, it is hypertonic, as a result of which the fishes are faced to these fishes have to face the problem of osmoregulation. Now what happens? These sharks retain large amount of urea in the blood and even the tissues, so that the body fluid of the shark and the water of the ocean, they become isotonic. They are same now by retaining large amount of urea. As a result, the problem of this osmoregulation is tackled. Even the concentration of sodium and chloride in the shark's body is less than the concentration found in the seawater. Uh, Sodium and iron chloride concentration is less compared to the amount of sodium and chloride that is found in the seawater. Therefore, what happens? These ions easily diffuse into the body across the gills, and then they are absorbed with the food. Then how to remove this excess amount of sodium and chloride? These cartilaginous fishes have rectal glands in the rectum region that removes excess sodium and chloride ion from the blood, and that is released into the rectum, and then it is eliminated or pushed into the surrounding water. See how efficiently the cartilaginous fishes show adaptation to osmoregulation. As far as maintaining the buoyancy in the marine water among the cartilaginous fishes is achieved by two ways. One is caudal and pectoral fins. They generate uplift as the fish swim, and because of the lift that is provided by caudal and pectoral fin, the fishes remain at same level in the water as long as it keeps moving. But once stop, it cannot maintain that. So an upward lift is provided by the caudal and pectoral fins when the fish is moving. So as a result, the fishes can maintain the same level in the water till it continues swimming. Then another important thing in buoyancy, it stores large amount of low density fat or low density lipids in their livers. Lipids are nothing but oils. All of you know they are lighter than water, isn't it? If you put a drop of oil on a water, it floats because it has low density. So for that reason, they store large amount of low density fats or lipids in their livers. This lipid gives the shark more buoyancy by reducing the overall density of the body. So the cartilaginous fishes includes mainly the sharks, skates, rays, chimeras and ratfishes or ratfishes. Nearly all of them are marine. Out of these, there are 350 species of sharks, 500 species of skates, and 30 species of chimeras. That is what you call ratfishes. So this class Chondrichthyes with skates, rays and sharks, they are the main predators since last 350 million years in the ocean. Now altogether there are under 1000 living species, and it is also believed that all these Chondrichthyes descended from ancestors that had boar. Actually, Chondrichthyes, though they are considered as the oldest fishes, still there is one interesting fact that ancestors of the Chondrichthyes were having bony endoskeleton. But later in course of evolution, This bony endoskeleton got changed into cartilaginous endoskeleton. Even these cartilaginous, these chondrites, as I have told you, they are the ancient group. Not much diverse because altogether there must be 100,000 species. Not as diverse as bony fishes. But the but for the fact that these cartilaginous fishes have not underwent any evolution, unchanged for hundreds of millions of years, they are continuing with the same shape, size, structure without undergoing any changes. Probably the oldest ancestor of this chondrites, we find it in early Devonian period, which is something 416 to 360 million years back. Although there are some older fossils are available, but the most unambiguous, where there is no doubt, undoubtedly we can say that the chondrites were found in the early Devonian period also. Probably there must have been one large extinct genera, what is known as Cladosalaci, a marine predator, was found in the fossils of this Cladosalaci has been identified, which is from the Devonian period. Even if you see this Cladosalaci, it was almost like a shark-like appearance, measuring about 2 feet in length and 3 prolonged teeth. So that is the Cladosalaci. It has 2 dorsal fins, each preceded by a large spine, a dorsal fin, that the fins on the back. You know the position of and name of the fins because in the last class only I have, with the help of a picture, I have shown you what are the different names attributed to different types of fins. So here also on the back there are 2 dorsal fins and each fin is preceded by a large spine. The pelvic fins and pectoral fins are paired even in the Cladosalaci, like the present day sharks, but the difference is the fins were having much more broad base compared to present day sharks. Broad base was there, but the tail was asymmetrical externally. The tail was symmetrical externally but asymmetrical internally. If you see the notochord extending into only the upper lobe of the tail, not to the lower lobe of the caudal tail. The notochord was extending to the upper lobe of the tail. See, the Cladosalaci must have looked like this. It was having 2 backbone dorsal fins, and just before the dorsal fin there was a spine, very hard spine. Externally, this caudal fin appears in symmetry, but remember it is internally more asymmetrical because notochord proceeds only to the upper lobe, not to the lower. Probably by Jurassic period, something 200 to 146 million years back, modern sharks must have evolved from this Cladosalaci. Because we know, even today we have several genera of sharks living. What is the distinctive feature of the modern shark? The modern shark has a rostrum or snout that overhangs the mouth. Actually, mouth is below At the tip there is a rostrum, but in case of the Cladosalachi, you can see the mouth is at the tip. But in case of the modern shark, the mouth will be somewhere here. There will be rostrum. This is what is called as rostrum. So here, uh, solid calcified vertebrae, though they are cartilaginous fishes, the vertebrae of the vertebral column are solid with calcification. That is the deposition of calcium material. And the modern sharks have the teeth which are covered by more enamel. Enamel is the hardest part. So the teeth are externally covered by this enamel. An example, megalodon is another, it's an extinct shark actually. It's a modern shark, but now you cannot see that, it has become extinct. That is the largest predatory shark that is known to us. Something 28 to 1.5 million years back, the megalodon was there, which was measuring approximately 16 meters in length. And entire body used to weigh about 47 metric tons, that is 470 quintals. So it was measuring about 16 metric ton, it was measuring about 16 meters long, and the used to weigh about 47 metric tons. Almost it resembled the present day great white shark. During that period, this was the apex predator, major predator in the ocean. See, megalodon, this is the megalodon size, and this is the whale shark, this is the great white shark, and see, compared to the size of the human being, how big they were. It was the megalodon, whale shark, great white shark, and human. The teeth of the megalodon was like this. See the size of each teeth and how they were arranged in the jaws, the megalodon. Now, fortunately or unfortunately, it is extinct now. Yeah, inside the mouth, a human being can easily sit. But nobody dared to sit. Now, coming to the extant shark, that is the living sharks, there are about 100 living species, 1000 living species in quantities, that is divided into two distinct groups. One is Neoselaci, also known as elasmobranch fishes, also known as elasmobranch fishes, Neoselaci, which includes these sharks, skates and rays. Out of 1950 species are from Neoselaci. And another small group that is known as holocephali, popularly known as rat fishes. There are about 33 species. So this Neoselaci, it has again three groups. One is Galeomorpha, which includes 279 species of shark. Then Squalomorpha, about 124 species of deep sea sharks, dogfishes, and Betoidea, which includes skates and rays, and something 534 species. We need not go to this much subtle level of classification. Now, after understanding the importance of these characters of the chondrichthyes, we will move on to the study of some of the types. First and most fascinating one would be the study of sharks. So this is some of the photographs of different types of shark. When I say shark, it doesn't refer to one species, but it refers to about 279 species. Shark, the most typical sharks, they measure about 2 meters long. But as you know, even the present day living sharks also may range in size from few meters, few miniature forms, where the size of shark may be about 25 centimeters. And perhaps the longest one measuring up to 18 meters. 18 meters. So there's a great variation in the size class. Some of the sharks, some species of sharks are very small, about 25 centimeters, and there are some which can grow up to 18 meters. Irrespective of their range of sizes, either it may be a miniature shark or a gigantic shark, all modern sharks, they have certain common characteristics. See, these are some of the sharks. Great white shark which can grow up to 6.6 meters. Smooth hammered shark which can grow up to 2.5 to 4 meters. This is hammer. This is also hammer-headed. This is the great white shark. I have told you the mouth is not at the tip. See, here there is a rostrum overhanging above the mouth. Megalodon was having the mouth somewhere here at the tip, but here in case of the sharks, present day sharks, the mouth is little bit below the anterior-most region on the ventral side, and some portion of the body is drawn forward and hanging above the mouth. That is what is known as the rostrum. So the sharks are like lion and tigers of the sea because they are the top predators. They hunt predatory organism. So that's why, being a top predator, they have a very important role of maintaining the ecosystem in balance. Ecosystem in balance by feeding the other organisms. Usually what they do is they are also equally important for the health of the biota, because mostly the sharks hunt older, weaker and sick prey which can be caught easily, so that their prey population will be in good condition. If you look into the anatomy of the shark, see, this is the photograph which explain you all this is the mouth, this is the rostrum, and this is the dorsal fin. There's also one more dorsal fin. This is the pelvic fin, pectoral fin. This is the pectoral fin, this is the pelvic fin, and then there's a caudal fin, heterocircle tail. See, one lobe is larger and the other one is smaller. Such tail is known as heterocircle tail. So these sharks are amazing fishes. Even they were found when the dinosaurs were there. And they are found in all waters all over the world, in every ocean. There are certain freshwater sharks. I have told you most of them are marine, but there are 2-3 exceptions, what we call freshwater sharks. Sharks have no swim bladder. No, not only shark, no member from these chondrichthyes have swim bladder. The biggest shark, what we call whale shark, can grow up to 15 meters long. It's a filter feeder. It sees enormous amount of water and filters planktons to eat through the gills as it swims. Probably this is the biggest fish. And the second biggest fish and the shark is the basking shark, which is about 12.3 meters long. This also filter feeder. Whatever the thing that comes in the water, it is filtered and eaten. Another biggest carnivorous shark is the Greenland shark and the great white shark. Both Greenland shark and great white shark grow up to 21 feet, that is almost 6.4 meters long. Even the grey white sharks can grow up to 11.3 meters, have been reported but not verified. But the verified one is 6.4 meters. So the largest shark which were known was Megalodon, which we have already discussed. It was 40 feet, 12 meters length, and it is no more. It has become extinct. So after having the knowledge of some of the largest sharks, it is also important to know the smallest sharks. For example, dwarf lanternfish is about 19 to 20 centimeters in 19 to 20 centimeters, whereas females are 16 to 17.5 centimeters in length. Another one is spined pygmy shark. Maximum is 21 centimeters. One more shark, pygmy ribbon-tailed shark, which is about 15 to 16 centimeters. Fully grown female can be up to 18 to 19 centimeters. These sharks, most of the sharks being the predators, they are most dangerous. Especially oceanic white-tipped sharks are the most fearless predators. A scientist, Jacques, who has done or studied the behavior of the shark, he said that the only species that the great white shark, it is never frightened by the oceanic divers or anything, but other sharks may be afraid of the deep water divers and other things, but not this white-tipped shark. And most dangerous of all the sharks. Among the shark, there is also one more shark, that is thresher shark, with the longest tail among the shark. The length of the upper lobe, see, the length of this is almost equal to the length of this body. This length and this length is one and the same. So the sharks have backwardly directed teeth. The strong and their bite is very strong. For example, the dusky shark, if you measure that, it puts 132 pounds or 60 kg of force per tooth. This is also done by in a study. But among the sharks, the most common one is piked dogfish shark. Very abundant, especially in the North Atlantic Ocean. It is on an average 1 meter, 1.5 meters in length. The sharks, the whale sharks, once long thought to be oviparous, um, and the egg was collected in Gulf of Mexico. The egg was something 36 centimeters. largest egg in the world it was considered. Uh, but now it has been found that uh, actually these whale sharks are viviparous, giving birth to live young. One particular shark, that the Portuguese shark, it can dive down up to 9,000 feet, that is 2,750 meters, almost 2.5 kilometer depth it can dive. These sharks are also known for migration. For example, blue shark, which can migrate from uh, 2000 to 3000 kilometers in seasonal journey. It was recorded by radio call rate. One of the blue shark can swim or migrate from New York State in USA to Brazil. The distance is almost 300 kilometers, 3000 kilometers. Sorry. One blue shark which was caught, it was having 139 pups in her uterus. See that the largest litter in the uterus, there were 135 young sharks were there. So this is this is the hand drawn diagram actually. This is the, see the mouth which you can see here. This is the snout or rostrum. Mouth is not at the tip, but it is subterminal on the ventral side. There are 5 pairs of gills. 5 this side, 5 to 7 in all contractiles. The number of gills which are open, their number of gills ranges from 5 to 7 pairs. This is the pectoral fin, pelvic fin, anal fin, and the caudal fin. I have told you that the heterocircle, see, it has one large lobe and another one is the lower lobe will be small. So this type of tail we call it as heterocircle tail. So this is the cartilage, flexible. So that's why if you if you eat shark, you need not worry about getting punctured by the spines of the fish. Otherwise, you know, all other fishes have spines. You should be very careful while eating. But here, in case of the shark, that problem is not there because the entire endoskeleton is made up of cartilage. Then there are, I have told you already, just to summarize, 360 species of shark, even very small to very large. The smallest shark is the pygmy shark and largest in the whale shark. So this respiration is through the uncovered gills. What happens is water enters through the mouth and it is forced through the gills. So these gill lamellae remain, gill rakers remain bathed in the marine water where the gaseous exchange takes place. And when the water flows, the oxygen is extracted. So most species of shark can pump water over their gills. When they are moving, undoubtedly they suck water from the mouth and force it out through the gills. But when not moving, they have to use the spiracles. There are a small percentage of sharks where there are no spiracles. If they have to survive, means they have to stay in constant motion to undertake the respiration. Once they stop, there is no supply of oxygen. So that's why continuously they swim. This is the teeth of the shark, backwardly directed, and once it is removed, the teeth grows, and teeth are not attached to their jaws. Front teeth are mostly needle-like, and at the back there may be some flat teeth. Teeth are grown and replaced often, and they have a multiple rows of teeth, not single row. So that's why a shark can have 25 to 30,000 teeth in its lifetime. Some of the sharks replace their teeth for every 8 to 10 days, and some over every few months. Lifespan, they most live about 20 to 30 years. Common. Spiny dogfish can live up to 100 years, and the whale shark can live over 100 years as well. The sharks have a very powerful olfaction, incredible sense of smell. They can detect the amount of blood if it is in parts per million. Even if a small drop of blood falls in the water, means the sharks far away can sense the smell and rush to that spot. So mostly they rely on their sense of smell to locate the prey. One is sense of smell, then other sense organs refers to the lateral line, the mid-ventral line, which if there is a photograph, I can show you clearly. If I am searching, yeah, here there will be a mid-ventral line, not shown like this. A line will be there. That is known as a lateral line. And this lateral line is very important here in the as a sensory smell, for sensation. They can detect the vibrations in the water. Even they are having some electroreceptor which help the shark to sense the minute electricity, because when the muscles contraction takes place, nerve impulses carried out, some amount of electricity is generated, and these sharks can sense even this low, very minute electricity caused by the muscle and nerve contractions. Thereby also they can locate the prey. The sharks have eyelids, but the eyelids do not blink. Usually the water which surrounds the eye cleans it. And sharks have a membrane over the eye that helps to protect the eye during predation. Great white shark has the capacity to roll the eyes back when attacking the other things. Do sharks sleep? Even today it is unsure. Possibly they may sleep like dolphin. Dolphin also never sleeps. Half the brain sleeps at a time. Remaining half the brain remains active. So I have told you the sense, even if you dilute the blood by 1 upon 10 billionth of their original concentration, they can sense. Excellent vision, even in dim water also. Shark attacks are now and then we hear. There are 32 species which attack even the human beings. 80% of the sharks are harmless. But see the photograph. But we human beings are not so. Usually 50 to 75 shark attacks will be there every year, with every year 8 to 12 people die. But in contrast, every year we kill 30 to 100 million sharks. Shark attacks are common, usually occurs in sandbars or by river inlets at that regions. But more dangerous thing is our attack on the shark. See, this is some total world. This one, 2000 there were 79 attacks, 11 people died. 2005, 61 attacks, 4 deaths. In 2006, 62 attacks, 4 people died. Most of the attacks are in United States. And especially the great white shark, tiger shark and bull sharks are mostly responsible for this. The great white shark, which can grow up to 13 to 16 feet, and they can easily camouflage themselves. The typical prey, the food of the shark is other rays, tuna, smaller sharks, dolphins, seals, sea lions. The natural food. Sometimes they may occur. The attack from below at fast speed even on human beings also. The tiger sharks hunting, see the teeth of the tiger shark, and they circle the prey, and then in groups they hunt, and entire prey is devoured, eaten. Especially this is the reason where most of the shark attacks comes in USA, Hawaii. Another one, the bull shark, highest threat to human beings because it lives in shallow water, very close to the beaches, and even males can grow up to 6.8 feet, female up to 11.5 feet. So they bump and bite, they circle the prey and eat. Many of the sharks, they have territorial, they maintain their own territory. Why sharks attack human being? Not known. Most of the time it is mistaken identity. They think that human beings are also prey. Or sometimes they want to taste a new food. As all of us are interested to have the new variety of food, probably shark also think that human being will be a very right food for it. So there is one thing where there are dolphins, sharks do not attack the human beings. That is also a very interesting thing and not known why. So these are different photographs of the shark, and I will continue about that in the next class because already the time is out for me and I cannot